Now we move on to Euclid's division algorithm. Now these two are two different things. One is Euclid's division lemma. Lemma is a statement that is proven, and then you can use that statement to prove another statement. An algorithm is a sequence of steps, iterative steps. Iterative means repetitive steps that are done in a specific sequence in order to achieve a certain result. So Euclid's division lemma is the statement that A is equal to BQ plus R. And Euclid's division algorithm is to use this statement to find out the HCF, that is the highest common factor of any two given numbers. This is not the only scope of this theorem, of this algorithm. You can do a lot more things with it, but that is beyond the scope of our syllabus. So coming back to that, Euclid's division algorithm. Let's look at an example. I want to find out the HCF of two numbers. HCF of, let's say, 455 and 42. This is what I need to find. So what we do, we will use Euclid's division lemma. See, step 1. How can we do this? Let us divide. Let us first call this A and call this as B. So if you divide A by B, you will get a quotient and a remainder in the form A is equal to BQ plus R. That is the statement that we want to find out through this. So let us divide 455 by 42 in our rough work. So 42, ones are 42, remainders is 3 and 35. Now remember the condition, the remainder should be smaller than the divisor. This is where you stop the division. So we can write 455 according to the lemma as equal to 42 times 1 plus 35. So this is again of the form A is equal to B into Q plus R. Now we repeat this process, but now we change the values of A and B. If you see, we obtained 35 as the remainder and 42 as our B. We will use these two numbers further. See how? Let us divide 42 by 35. Let us express 42 in terms of 35. So what we will get? Let's see. So 42 divided by 35. So 35 ones are 35 and our remainder is 7. We got the remainder smaller than the divisor, stop the division and then write the statement. 42 is equal to 35 times 1 plus 7. So we write here as 32 times 1 plus 7. Again, A is equal to B into Q plus R. Now we have these two numbers, 32 and 7. I'm very sorry, this is 35. Now we'll take these two numbers and repeat the procedure again. Third, step 3. 35 can be expressed as 7 times 5, because 7 5s are 35, plus 0, because 35 is a multiple of 7, so the remainder is 0. The moment we get the remainder as 0, whatever is your divisor, that divisor is called as the HCF of these two numbers. This is how we find out highest common factor using Euclid's division lemma repeatedly in the division algorithm. Let us check if our answer is correct. Our two numbers were 455 and 42. Let's factorize this. 5 91s are 91 comes in the table of 13. 13 times 7 and 7 times 1. Next we have 42. 7 6 are 2, 3 are 3, 1s are. Remember that I can do this factorization in any sequence because it is unique. This we are going to study in the next topic, fundamental theorem of arithmetic. No matter in which sequence you do the division, you will get the same sequence again. So if you see, 7 is common to both and no other factors are common to both of them. So 7 is our HCF. Hence we have verified our answer. So we'll list out Euclid's division algorithm as follows. Let's say we have two numbers C and D whose HCF we are interested to find out. So first step, step 1. By Euclid's division lemma, obtain two numbers Q and R which satisfy C is equal to DQ plus R, where R is less than D but greater than equal to 0. Step 1. Step 2. If R, that is the remainder, is 0, then D is your HCF. If not, go to step 3. If R is not equal to 0, continue the steps till you get the remainder as 0. The moment you get the remainder 0, whatever divisor that you will have will become your HCF. Now this method works because the HCF of C and D is same as the HCF of D and R. Let us verify this. So our C example, in our example was 455 and D was 42, for which we got D is the same thing, for which we get the remainder in the second last step as 7. So if you find out the HCF of C and D, we have found out that to be 7. And if you find out the HCF of D and R, obviously you can see that 7, 6 are 42. 7 is the only common factor. So 7 is the HCF of D and R as well. And this is why Euclid's division algorithm works. In previous classes, if you were asked the question, represent a even number. We know that even numbers are 2, 4, 6, 8, 10 and so on. These are all the numbers in the table of 2. And the numbers which are not in the table of 2 are called as odd numbers, which are 1, 3, 5, 7 and so on. If you wanted to represent these numbers using a general result, using a general expression, how would you do that? If you remember, we used to write all even numbers as 2q, where q is taking all the values of natural numbers. So if q is 1, your even number is 2 into 1 is 2. If q becomes 2, the even number is 4. If q becomes 3, the even number is 6 and so on. What if now we want to obtain an odd number? It's very simple. Either we add 1 to this or we subtract 1 from this. So we have either 2q plus 1 or 2q minus 1. Now which to use when? Now suppose I want all the numbers, odd numbers 1, 2, 3, 1, 3, 5, 7 and so on. I want these numbers to be generated by these expressions. So if I start q from 1, then I'll have to use this result. How come? 2 ones are 2 and 2 minus 1 is 1. So this generates this numbers when q starts from 1. And when does this generate? It starts, if q starts from 0, then 2 into 0 is 0 plus 1 is 1. And then if you take q is equal to 1, the next number is 3 and then so on. So this expression will be used if q starts from 0. Fairly simple. Now, how do we know that we have to use this? If you observe carefully, this is nothing but division lemma. How? See here, q, let's take any even number. Let's say I take 40. So I know that twice of 20 is 40. So I can write 40 as 2 into 20 plus 0. Division lemma. Similarly, if I want to write any odd number, let's say I want to write 15. So 15 can be written as 2 into 7, which is 14, plus 1. So A into B, A is equal to B into Q plus R. Again, this is division lemma. So this lemma gives us a very powerful result that we can use to solve problems. How? We are going to see in the exercise 1.1 of NCERT, as well as a few problems of R.D. Sharma, which will be the assignment of this chapter. Thank you.
Click on the bell icon and never miss another updates from AIMS.